It's our turn already. So I think this page kind of says what our goals were, is that we wanted to make a mooring page and we wanted to dig into some of our mooring data, as a few of us came together and realized that we have lots of it, but we also wanted to be fancy. So this is in our pursuit of fanciness and sharing this fanciness with others, in that we directly stole the OceanHackWeek website and then kind of took it apart and repurposed it for our, needs. So what we're going to try and do is each of us ended up, there was two kind of sections where some people wanted to dig into the mooring data processing, just kind of building that processing pipeline in Python. And then some of us also wanted to focus on this data viz part, because there's tons of ways you can visualize and make interactive plots, but then there's also this component of like, can we get it to work on a web page? Can we get it to work at all? So what we're going to try and do is go through super quickly, a number of us from our team, just kind of saying what we wanted to. I'll just take a minute and say, so this site, we are experimenting with making pages just using Markdown as well as Jupyter notebooks, and there's a whole other, I feel like there's a million things we can do. Just a shout out to our team. We had a lot of collaborators, and yeah, so thanks for the help from the mentors and just all the contributors for being involved. And I'll state our general goals was that accessing mooring data, visualizing the data, and having some fun making a web page. So I'll move on next to, let's start with the DFO data. So Sam and Lou are going to quickly go over a couple of the notebooks that they put together.
Thank you. So I started off by, we've got at DFO in the Pacific, we have quite a few moorings that we monitor. We've got quite a few years of time series, and we want, although this data is available, we would like to make it a little more user-friendly and like to present it to a lot of people so that they can get a snapshot of what it is. So there's a sample of our moorings that we have. The blue one there is the one that we chose for this project. What I started with was just downloading the data as we normally do in a large NC file, just to have a look at it, while Lou was looking at downloading it through the ERDAP server directly, so that we could get a bit of a sense of how the users use it. And I just put together some plots of what it looked like, to look at some data gaps and to look at some issues we had with how our data is stored and how outside users might use it, and how we can make some plots that make it a bit easier for people to look at. And so I'll pass it on to Lou.
The next page. Yeah, as I mentioned, so we kind of aim for generating and display some long-term time series of mooring data in different ways to support our monitoring programs. So the data plus types include the raw data time series from different depths of the fixed depth moorings, and also including like the climatology plots and anomaly plots on different temporal scales. That's what I kind of like aim for. But through this practice, we do find a lot of problems in our data files in our archive in the .net/CDF format. So which brings some work for us to fix those files after return. So on this page, we start from like the EO1 as one like a practice. Let's scroll down, and also it's like there's a search funding polygon on the map. And then we kind of like check the depths of the data. Like you can see, we have a lot of data from 3 different depths from this mooring site, and then start to do some plotting to check the long-term time series collected at different depths. And then I haven't got there, but it's on the list. We'll do the climatology and anomalies plot. So this one is kind of comparing the temperature salinity time series at from different depths, just to see like what's the variation or the difference among different depths. Yeah, so that's the plan. Like the way we're gonna, after this project, after go back, we will kind of generate the standard data page for each of mooring long-term monitoring mooring sites. Yeah, I'll pass to Happy.
Yeah. So there is another station known as police station, controlled by Seth and his team. So the main goal also is to try to see ways by which users can access that platform and see and check the data set. So they have like 6 mooring over there, and I picked like the 2 that is closest to the influx from the Pacific Ocean, which I read over there. So the first thing that I did was to try to make user, if they just want to extract the data set at a specific date, and also compare like 2 moorings, which is this time series over the entire data available. So, and the next thing was also to make kind of depth profile comparison, but first looking at one of the stations. So if user just want to like check the data at a particular station, which is this temperature, salinity, and oxygen, the 3 major variables we are focusing on, and also making comparison between stations like intraspace station comparison, which is this. So one of the other data set they have is climatology and anomaly. So we also like create script by which user can access those data sets also.
And Hafiz made some really amazing plots of climatologies.
So this is the depth profile of the climatology temperature salinity at one of the stations. Fortunately, that's not during.
It's true. We had to put the other nice one here.
Okay.
We got it out.
So now comparing climatologies between stations also. So this is the result.
So now we'll move over to some of the interactive visuals that our team played with. I very quickly had a chance to try Shiny, and you can see the result here. Now I'll turn it over to Seth, who tackled HoloViz.
Yeah, I feel like the piece that we were taking away from, particularly the interactive part, is just how hard it is to make things interactive. So we were trying a couple of different things. If you want to just click Hollywood's page. So to start with HoloViz, we started to, same thing as the others, we downloaded some of the data. We were just trying to make some simple plots to see what we could do. Yeah, this is good. And so the first piece was, before we could even make an interactive web page, we just had to make an interactive notebook. And so we were using this piece where you could create this slider widget that would load up into the notebook. And then, yeah, this is a static page. The widget's not static, but the page is. Actually, if you scroll just a little bit. And you can end up seeing that in that code, there's these different ways in which you make it interactive, but then also how you select the data and how you reference that slider to feed into that interactive data set that you have. And so this is one of the pieces that I ended up finding, was that there were so many different ways that you could end up making it interact with itself, that it sort of became difficult to know which way was actually going to work for you. But yeah, so this is just one way in which you would slide. You could use the slider to move between different cast start times, and it would create a profile for you. We would certainly like to make that a prettier looking plot, but it's a nice place to get going from when you do have the interactive piece. After we did that, then we went on and tried to make it into an app that you could have running on the website. So if you wanted to have something live running on the website, you actually need some sort of server running alongside it that could load up with it. And so to do that, you have to make this function that then gets fed to this HoloViz panel. And that panel can be servable, is what they call it, so that you end up creating a runtime that goes with the website. And when you have that, then you can take that that panel, you can add all sorts of controls on it such that you can control the time range, depth range. You could add checks so that you could remove different levels of quality control data. So it's really quite flexible once you know what you're doing, but I found like I spent all this time working on that, but in the end it was like 4 lines of code. So it was quite a journey to get to that spot. But once you have that server going, it's great. However, I never got the server running for Viz, but I believe that Veronica did for Streamlit, and so I'll pass it over to her.
So
Hi.
1 minute.
Oh, okay, thank you. Hi, so I was tasked with investigating how we could use a Python library called Streamlit to visualize data and make it interactive. And it was pretty straightforward in theory, but I ended up having to do a lot of research because I was new to this. So read up a lot on documentation, did a lot of testing, trial and error, but eventually finally got a couple example graphs to share. So this first one here shows how you can select different variables to display on a map. You can also zoom in to an area to get a closer look, pan across the graph. If you hover over data points, it should give you values. So this is all through Streamlit. Streamlit allows you to create graphs a number of ways. You can either use their built-in functions for plotting, but you can also use it as kind of a wrapper around matplotlib or plotly and other plotting modules. So there's a lot of flexibility with how you create these visualizations. Down below, we have a static plot with a table of values below that. So this kind of just gives a basic use case of Streamlit on how you can show your data. So this is deployed through Streamlit's community cloud. They provide one for free. So you create an account and you point it to your GitHub repository, and it develops this web app that you can then share publicly. So that's the process that I use to get the shareable URL. Yeah, so there was a steep learning curve for this, but in the end, I think it's a pretty powerful tool that is great for developing data dashboards, and I look forward to exploring this more beyond this OceanHackWeek. There is a Jupyter notebook in our repo that gives instructions on how to recreate this specific app that was developed. So if you're interested in learning more, highly recommend checking that out or reaching out to me.
And I think that's pretty much a summary of our site. So thanks again to all the people that were involved and Ocean Hack Week, and yeah.
Thank you. Does anyone have any questions? Looks like no. Oh, who has a question?
So you tried a bunch of different visualizations and sort of creating interactive dashboard sort of thing, widgets. After all that, and if you were to do it again, which one would you focus on?
Well, I focus on HoloViz because that's the one I learned.
The other people
Yeah.
too, right?
Yeah. I think they both have fairly nice features. I didn't find that they were particularly different. It's just slightly different syntax of how you do the exact same thing. The HoloViz one, the piece that I was hoping to be able to learn more about was creating those sort of custom functions on the inside. I didn't see how I let Veronica speak to how easy that was to do with Streamlit, but for HoloViz, once it's basically you write a function and then you say, go plot this function, and it will update it for you. So it's kind of cool. That seemed fairly simple.
Yeah, Streamlit works similarly. It also has the ability to create a layout and format it. So you can really design a nice dashboard with a bunch of different features. You can add drop-down boxes, you can have images, maps. So it's pretty powerful. And as far as which one I would use, I also only focused on Streamlit, so I wouldn't be able to expand on like a comparison between the two, but there are a bunch of data visualization tools out there. So there are some resources that compare these, and that might be a good way to help you choose which one you want to go with if you ever interested in exploring one of these.
As a last piece, one thing that I did think was funny with that as I was trying to learn about it and really deploy it, I kept finding things like, do you have a Streamlit app? This is how you convert it to HoloViz, and just back and forth. So these things, they're pretty flexible, and there were only a few lines of code you had to change for each thing to fairly quickly deploy it in the other system.
Thank you. And so now we'll move on to our last group.